Okay, we are going to review for test 2. And the test covers these sections here, 1.6, 1.7, 1.8. I'm going to leave out 2.1. We did cover section 2.1, but I don't have anything from the test for that. Then we have 2.2, 2.3, 2.6, 6.1, and 6.2. So let's dive right into the review assignment. And question number 1, we have find an equation for the tangent line to the graph of y equals x cubed minus 16x quantity to the power of 12. And that is at the point 4, 0. So when you do these problems, and there will be a problem asking you to find the equation for a tangent line in some form or another on the test. So when you do these problems, the first step is to calculate the derivative because that gives us the slope of the tangent. So we have here y prime. I'm going to use the power rule because this power here is a constant, so that requires the power rule. So I'm going to bring that out front. And then I'm going to subtract 1 from 12 to get 11. And then because the inside here is not just plain old x, it's another function of x, I need to multiply by the derivative of this function. So I'm going to multiply by 3x squared minus 16. And now I want to evaluate that derivative at the point x equals 4. So I'm going to plug in 4 here. And that will give me that my slope of my tangent at this point is 12 times the quantity 4 cubed minus 16 times 4 raised to the power of 11 times 3 times 4 squared minus 16. And you'll notice this is 4 cubed and 16 times 4, that also is 4 cubed. So we have 64 minus 64. That gives me 0. And 0 to the 11th power is still 0. Anything multiplied by 0 is just 0. So that's my slope. And when you have 0 as your slope, that is a horizontal line. Okay, so the next step would be to find B. B is the y-intercept. All right, so you're going to take x equal to 4 and you're going to plug that in to your original. That's going to show us where this point is. So when we plug in 4, we get 0. And so the constant, let's see here. So we have y equals 0 times x plus b. So in other words, y equals b is the equation of the line. And where does it cross the y-axis? Well, at 4, it's going to be at 0. So this is the y value at 4. And so therefore, b is your y value. So we have that y equals 0 is the horizontal line. And if you look at the graph of this, you can graph this on your calculator. So I'm just going to show you on Desmos real quick. So I'm going to type in y equals x to the power of 3 x cubed minus 16x, and that's going to be raised to the power of 12. And you can see here at 4, we zoom in, the tangent, now that looks like a solid line touching the x-axis, but it's just getting closer and closer. The tangent at 4 is the horizontal line here, and because it's on the x-axis, the equation for the x-axis is y equals 0. So that is our tangent at 4. Okay, just a second here. All right, so y equals mx plus b is generally what you're going to use, and in this case, b is 0 and m is 0. So what we get, y equals 0. Okay, now number 2. We want to differentiate. For most of the test, you're going to be, if not for every single problem, probably honestly, every single problem you're going to have to differentiate, and that means find the derivative. Some of them are application problems, but since this is a derivative test, even in word problems, you're gonna have to take the derivative somehow. So when it says differentiate, that just means find the derivative. So we have here y equals 5x times 8x squared minus 4x. And you can see we have a product of two functions, but because this is just one term, it might just be easier to go ahead and distribute that. So you could just go ahead and multiply 5x and you get y equals 40x cubed minus 20x. And then you can apply the power rule when you take the derivative. And so we get 120x squared minus 20. And oh, I forgot to multiply by x squared here. Let's go back to that. So 5x gives me the 40x cubed, and here 5x times 4x, I forgot my square there. So when you differentiate, that's going to be 120x squared, and then you're going to take 2 times 20, that's 40x. Okay, that's better. So 120x squared minus 40x is right here. Now, here you could use the product rule, or you could FOIL it. Either way, I think using the product rule is probably easier because we have two binomials, whereas in the last problem, we had just one single term here multiplied. And so it was easier just to go ahead and multiply first and then take the derivative. But in this particular example, I'm going to use the product rule. Section 1.6 covers the product rule and the quotient rule. So most of the problems from that section are wanting you to use the product rule. So this will be number 3, and we have y equals 8 minus 5x squared times 5x squared minus 100. And as a reminder, the product rule is when you have two functions multiplied. So the first function would be the 8 minus 5x squared. The second function is g. And when we multiply them to find the derivative of that product, by the product rule, your derivative is going to be the first function, which is f, multiplied by the derivative of the second function, plus the second function multiplied by the derivative of the first. So this is the rule that you're going to apply. So to the side here, I'll go ahead and calculate g prime and f prime. So f of x is the first function. So f prime of x is going to be, well, the derivative of 8 is 0. The derivative of negative 5x squared is negative 10x. And then your g of x is your second function, which is 5x squared minus 100. And the derivative of g prime of x is going to be 2 times 5, that's 10. And you subtract 1 from the exponent, so you get 10x. Now I have all of my 4 functions here. I'm going to plug them into this formula. So that gives me that y prime is going to be 8 minus 5x squared multiplied by g prime, which is 10x, plus g, which is 5x squared minus 100 multiplied by f prime, which is negative 10x. And if we sort that all out, if we distribute, here we're going to distribute 10x to each term, and here we're going to distribute negative 10x, okay? Now, so that gives us 80x minus 50x cubed. And then here, negative 10x times 5x squared is minus 50x cubed. And then the double negative here is going to give me plus 1000x. So we have negative 100x cubed, that's right here. And then we have 1080x. Looks like C is the correct answer. Okay, this problem is similar. I'll let you do this one on your own. Here you're going to have, if you multiply this out, you're going to have 6 terms because you've got a 2 by 3 here. So again, the product rule is going to save you some time. Let me just demonstrate the product rule again here. All right, so again, the rule is that you take the first function times the derivative of the second. The derivative of the second function is going to be 6x squared minus 2x. And then you add to that the second function times the derivative of the first. In this case, the derivative of 5x minus 5 is just 5. So you're going to want to have, here you're going to have to FOIL, here you're going to distribute. So when we FOIL, we get 30x cubed. The outside is going to give me negative 10x squared. The inside will be negative 30x squared. The last is going to be 10x. And then we've got 10x cubed minus 5x squared plus 5. So now we're going to combine like terms, and let's see, we have here negative 10x squared, negative 30x squared, minus 5. Here we have 10x cubed, 30x cubed, so it looks like 40x cubed minus 45x squared. And then we have plus 10x plus 5. So it looks like D is the correct answer. Another one using the product rule, I'll let you work that one out. I don't want to do too much. Let me go ahead and do this one here. In this particular case, I would go ahead and FOIL that first. You'll notice that we have plus x minus x, so some middle terms are going to cancel out. We're on number 7 here. So your y equals 4 over x plus x and 4 over x minus x. So y prime, or I'm sorry, y, if I FOIL that out, I get 16 over x squared, and then I get plus 4x over x, which is just 4, and then minus, that's going to cancel. And so my last term is going to be minus x squared. Now, sorry about that. I need to stop sharing so you can see that better. Okay, so I went ahead and FOILed it out. Now I'm going to go ahead and take the derivative. Here's the thing. When you have an x squared in the denominator like that, you can't use the power rule in this form. You need to change that. But when you have a denominator with a power like this is just y equals 16x to the negative 2. This negative means your x squared is in the denominator. So I write it like that so I can use the power rule. And so now I'm going to go ahead and take the derivative. Negative 2 times 16 is negative 32x. When you subtract 1 from negative 2, you get negative 3. And so here I'm going to get the derivative as minus 2x. And I'm not sure what format they have it in. Let me take a look and see at the choices here. They went ahead and put the x to the negative 3. They wrote it as x cubed in the denominator. So this becomes negative 32. This negative here just means I can put x cubed in the denominator. And this is the format that they want. So going back to the problem I have, it looks like D is the correct choice. All right, when you see a square root like this, you're going to want to write that as x to the 1/2 power. So again, since this is the section of the product rule, let me use the product rule for this problem. So we're on number 8. And I'm going to copy this down real quick. We've got f of x equals 5x minus 5. And then the square root of x plus 4. And like I said, you want to write this as f of x equals 5x minus 5 and x to the 1/2 plus 4. So now I'm going to go ahead and take the derivative. And because I have two functions here multiplied, I use the product rule. So we have f prime of x equals the first function multiplied by the derivative of the second. So I'm going to apply the power rule. The derivative of 4 is 0. So I'm just going to multiply by 1/2 x to the minus 1/2. I bring that 1/2 out front, and then I subtract 1 from 1/2 to get negative 1/2. So this is the first function times the derivative of the second plus the second function times the derivative of the first. The derivative of 5x minus 5 is just plain old 5. So if this were not multiple choice, I would just leave it like that. But since it's a multiple choice problem, you're going to have to simplify this. And so I'm just going to distribute. Here I'm going to distribute 1/2 x to the minus 1/2, and here I'm distributing the 5. So this becomes 5/2 x. Now, when you got x to the 1 power and multiplied by x to the negative 1/2, you add the exponent. So it's going to be 1 minus 1/2. So this becomes 5/2 x to the 1/2. And then we're going to have minus 5/2 x to the minus 1/2 plus x to the 1/2 times 5, I should say, 5 times x to the 1/2 plus 20. So my constant term is 20. So before I even do any more, let me just show you. You can eliminate some choices. Well, not in this example, but often you can eliminate just by identifying the constant term. So here, that's not working. But notice, if you will notice this, here we have 5/2 x to the 1/2, and then we have 5x to the 1/2. So this is going to be 7.5. So you've got 10. Let me see. I'm sorry, 12.5. No, wait, what am I doing? So we've got 10/2 and 5/2. So that's 15/2. Let me just write it out like that. 15/2 x to the 1/2. See how these are like terms? And then we've got minus 5/2 x to the minus 1/2 plus 20. Okay. Now the test is a mixture of multiple choice and free response. And I did that because sometimes multiple choice is harder and sometimes free response is harder. But what I'm doing is I want to give it a mix so that I'm going to keep the test as basic and straightforward as possible. I don't want to, so I probably wouldn't put this particular problem on there just because of the algebra is so intense. So let's see what we got here and compare. 15/2 is 7.5. So the choices narrow down between A and B. And my next term is negative 5/2, which is negative 2.5. So A is the correct choice. Okay. All right, moving on now to the quotient rule. So we're still in section 1.6, but we've covered the product rule pretty extensively. Now let's do the quotient rule. The quotient rule just is this. If you have y equals f over g, okay, that's a quotient when you have a fraction like that. And to find the derivative of that, you take the bottom function. You always start with the bottom function, g times the derivative of the top minus the top function times the derivative of the bottom, all divided by the bottom function squared. I'm going to give you this formula for the test. You don't have to memorize that. This is the quotient rule. And so when we use that in this particular problem, you can see that the top function, our f is x cubed and our g is x minus 1. So this is problem number 9. And we have y equals x cubed over x minus 1. So my top function, f of x, is going to be x cubed, and the derivative of that is 3x squared. And my bottom function is x minus 1, and the derivative of that is just 1. Let me stop sharing so you can see that. Okay, so here we go with the quotient rule. Here we have the top function and its derivative, and then we have the bottom function and its derivative. Now we just take all of this and plug it into our formula. So y prime equals x minus 1, that's the bottom function. You always start with the bottom function when you're doing the quotient rule. Multiply by its derivative, well, that's just 1, minus the top function, that's x cubed, multiplied by its derivative, which is, I'm sorry, the derivative of g, the bottom function, which is, let's see, we have the bottom times the derivative of the top. So this one is 3x squared. And then that's the f prime right there, 3x squared. And then we have f, which is x cubed, times the derivative. There we go. Okay. And then you take the bottom function, which is x minus 1, and you square it. All right. Now, if it's just a free response, you can just leave it like that as your answer. But this isn't too hard to simplify. So we're not going to do anything with the denominator. We're just going to leave it like that. And the numerator, we're going to distribute this 3x squared. So it's going to become 3x cubed minus 3x squared minus 1x cubed. There we go. And we have like terms here. So we're going to have 3x cubed minus x cubed. That is going to be 2x cubed minus 3x squared over x minus 1 squared. And sometimes it helps to look at the choices first before you simplify it, so you can kind of guide your simplification. So here we have the 2x cubed minus 3x squared. Here it looks like A is the correct choice. For some reason, this one ended up in there twice, so we already know the answer to that one. And now, same thing, I'll let you work this problem out. Notice that we have a 1 out here. Maybe I'll do this one just because of the way the answers are a little, yeah, let me do that. I think they ended up. Okay, so number 11, y equals x squared minus 4. And so using the quotient rule, because we have a quotient here, we're going to take the bottom function times the derivative of the top minus the top function times the derivative of the bottom, all divided by the bottom function squared. Okay, let me review that again. Bottom function times the derivative of the top minus the top function times the derivative of the bottom, all divided by the bottom function squared. And then we simplify that, we get 2x squared minus x squared plus 4. This 1 is really irrelevant because 1 times anything is just that thing. And I have to distribute this negative. So it becomes negative x squared. And then the double negative here is positive. Okay. Now, to me, if I were doing this, I would just write this as 2x squared minus x squared is just x squared plus 4 over x squared. But that's not the way they have it. What they did was split it apart. So they wrote this x squared over x squared plus 4 over x squared. So it's 1 plus 4 over x squared. So when you have a multiple choice problem, you may have the correct answer, but they have it in a different form. And that's where the algebra comes in. Like I said, I'm going to try to keep this test very simple so that you're not tripped up by the algebra. There will be some algebra that you're going to have to do ultimately, but I'm going to really honestly do my best to keep that at a minimum. All right. So this is the correct choice. 1 plus 4 over x squared is C. Okay, here we have another quotient rule. I'll go ahead and do this one as well. We have, this is number 12. So we have g of x is equal to x squared plus 5 over x squared plus 6x. Again, using the quotient rule, here we have a quotient of 2 functions. So the quotient rule, and this g, by the way, is the entire function. This is not the g in the formula. So be careful about that. We commonly use f and g to describe or name a function. And so the formula has those names. But when in the formula, that's why I always say the top function and the bottom function. So be careful that that you understand that. So when we use in the formula, the g in the formula is referring to x squared plus 6x, but in the problem, this g is the whole thing. So keep those two g's separated in your mind. So taking the derivative now of this quotient, And using the quotient rule, we take the bottom function. Remember, you always start with the bottom function when you're doing the quotient rule, multiplied by the derivative of the top, that's going to be 2x, minus the top function. And make sure you use these parentheses because we got to distribute that negative, times the derivative of the bottom. Okay, all divided by the bottom function squared. Okay. Now, what they did here, notice that there's a common factor of x. So in the problem, they take that common factor out. And so they replace this as x times x plus 6. And then they square that. And so they get x squared times x plus 6 squared. So this is the same as that. And so when we do this, we're going to work on the numerator now. We have 2x cubed. Okay, 2x cubed. I'm distributing this 2x here. 12x squared plus 12x squared. Now, I've got to FOIL this. So when I FOIL this, the first terms are going to be 2x cubed. And then we've got the outside 6x squared, the inside 10x, and then the last is going to be 30. And then I've got to distribute this negative to each term because I'm subtracting the whole thing. So this is going to become minus 2x cubed minus 6x squared minus 10x minus 30. And so the 2x cubes cancel here because you have a positive and a negative. And then we combine these. So this is going to be 12x squared minus 6x squared is 6x squared minus 10x minus 30 all over x squared times x plus 6. We don't want to forget the denominator here. All right, so this is your final answer. And again, there's a lot of algebra there. So I'm going to try to avoid these types of problems with a lot of algebra, but there is D is the correct answer. Okay, so just make sure you know how to apply I think in class I've been saying 14 rules. They're actually 12 because there are 8 on that first page. And let me just go over that again. If you go into Folio, here in the content section of Folio, let's see if I'm sharing the right screen. Looks like it. Okay. Scroll down here, basic derivative rules. Here's the link. And these are the first 8. And then if you scroll down here and click on this page, the first 4 are the ones that we're covering. So it's going to be, actually, I guess we're covering these as well. So yeah, it's the first, it is 14. I've been saying it correctly. 8, actually it's 16 technically, because this is the chain rule. Really, these rules here are a combination. So you don't have to memorize them. This is the step 1, step 2, step 3 that I've been doing. Okay, so anyway, so the first, going back here, we have this, the first 8, and then we have these rules for exponential functions and for logarithmic functions, okay? All right, I don't know why I didn't include these bottom ones when I've been talking about this, but anyway, just an oversight on my part. So make sure you go know these rules, at least how to use them. And moving on, let's see now. I'll let you do this one, another one with the quotient rule. Here's another one with the quotient rule. And so I'll let you work through Just remember, when you see a square root, you want to think of it as x to the 1/2. That's don't be bothered by square roots. It's just using the power x to the 1/2. All right, sometimes you're going to have to differentiate problems in a word problem. You're going to have to do, remember, this is a derivative test. So every single problem, you're going to take the derivative. So even if it's a word problem and it doesn't necessarily say find the derivative, when you say find the growth rate, you mean find the derivative. Okay, so here we have a function, p of t. This is number 19. And we have p of t is 600t over 2t squared plus 7. T is the time in months, and we're looking for the growth rate. That just means find the derivative of this function. So when it's written as a quotient, we're going to use the quotient rule. So p prime of t is going to be the bottom function times the derivative of the top minus the top function times the derivative of the bottom. Make sure you use these parentheses. And that's all divided by the bottom function squared. Distributing the 600 gives me 1200t squared plus 4200 minus 2400t squared over 2t squared plus 7. And so 1200t squared minus 2400 is going to be minus 2400t squared is going to be negative 1200t squared. And then we've got the plus 4200 over 2t squared plus 7. And I forgot my little square there. Okay, so looking at the choices here for this, it looks like, oh, they did not, so they factored out 600 because there's a common 600. They did not distribute this. Well, so I'm going to do one further step to match their choices here. And so that's going to equal, so when I factor, that's going to be 2t squared minus 7 squared. Is that right? Because I factor 600 out of here, that's going to be 7 minus 7 because this is negative. And then we have 2t squared plus 7 squared. And they don't have the negative out front. So going back, I'm going to multiply this negative through here and here because they don't have it out front. So I probably would avoid this type of problem on a test just because the algebra is, you're trying to match their choices. So this is going to become a positive 7 minus 2t squared. And then you've got the 2t squared plus 7 squared. I think I got it now to match their answers. So we have 600, 7 minus 2t squared. I think this is it right here. C looks correct. So you can kind of see what I was talking about. Sometimes it's hard to match their answer. You might have the correct answer, but it's not in the right format. So that's why I like the free response questions, because they accept so many different answers, and you don't even have to simplify it. And so it's much easier. So I'm going to try and keep it simple. Okay. These two problems got in by mistake. We did not cover these. And so I am going to just skip over 20, 21. I think I'm just going to remove them from this assignment. I did not intend to put these in here. So question 22 now, we're moving on to section 1.7. Section 1.7 covers the extended power rule. And so here we have a function, f of x equals 4x plus 3 squared, and this is problem number 22. So because this is a power function, we have a power here that's a constant. I'm going to apply the power rule when I take the derivative. So I have 2 coming out front here. Then I still have my 4x plus 3, and I subtract 1 from the power to get 1. And then after you've done that, you're going to multiply by the derivative of the inside. The derivative of 4x plus 3 is 4. So we're going to have 2 times 4 becomes 8 times 4x plus 3. And that is your derivative using the extended power rule or the chain rule. The extended power rule is just a specific version of the chain rule. The chain rule is the general rule. And so it looks like B is the correct choice. Okay, moving on now. Again, same similar sort of problem. This is number 23. We have f of x equals 3 minus 7x to the power of 300. And so taking the derivative now, we bring the 300 out front and subtract 1 from the exponent. That's going to become 299. And then by the chain rule or the extended power rule, you multiply by the derivative of the inside here. When I say inside, I mean inside the power, right? So 299, this is what's being raised to that power. So this is the inside. And the derivative of this is -7. So this becomes -2100 when I multiply these two numbers times 3 minus 7x to the power of 299. And that gives us choice A as the correct answer. All right. Now, this is the same thing here. The 3 comes out front. You subtract 1 from the 3 to get the square, and then multiply by 4x, which is the derivative here of the inside. So you're going to have 2x squared minus 7 squared, which is what we have in every single problem. But then you're going to take that 3 that was out front and multiply it by 4x. So it's going to be 12x multiplied. So A is the correct choice. Okay, this is a good one to do because this one we're using, well, we have a square root, and I just want you to understand that these are not hard. Number 25, we have f of x equals the square root of 1 minus 10x. Okay, so this is also using the extended power rule, but the power here is just 1/2. We're going to think of this function as 1 minus, and that I wrote that like that. I don't know why I did that. Hold on, let me double check. I'm sure that's wrong. Yeah, it should be multiplied by, it looks like a 10 to the x power. I meant to multiply it. There we go. So we have 1 minus 10x, and the square root just means we're raising it to the 1/2 power. So when we take the derivative, we apply the power rule. The 1/2 comes out front. 1 minus 10x. You subtract 1 from 1/2 to get -1/2, and then you multiply by the derivative of the inside. So that's going to be times negative 10 because that's the derivative of this inside function. So when we simplify that, 1/2 times negative 10 is negative 5, 1 minus 10x to the negative 1/2. And I'm not sure if they leave it in this form. Let's check the choices here. Nope, they convert it. So we're going to convert this back. The negative here means that it's going to be in the denominator, and the 1/2 means it's going to be under a square root. So this becomes negative 5, that's in the numerator, and then 1 minus 10x is in the denominator with the square root. Okay, so that's our final simplification. And it looks like this is the correct answer right here, C. All righty. In this particular problem, you can use the quotient rule, but you don't have to. You can use the extended power rule, because when it's in the denominator like that and your numerator is just a constant, you want to think of it. Now, if your numerator is a different function, then you would want to use the quotient rule. But since the numerator is a constant, you can use the power rule. And let me show you how that works. So we have number 26 here that we're working on. And we have f of x equals 1 over 5x squared plus 2. So let me show you how I'm going to convert that into a power function. The fact that it's in the denominator just means that I'm going to have f of x, I'm going to have 1 times 5x squared plus 2 to the negative 1. So this is just this is another way of writing this fraction, okay? And you say, well, what happened to the 1? Well, think of this as 1 times that. And we don't need the 1 there. We don't need to write it. So now when I take the derivative, I just apply the extended power rule because we have a function other than x here. So it becomes negative 1, 5x squared plus 2. And like I said, you subtract 1 from negative 1, you get negative 2. But like I said, the extended power rule is just another version of the chain rule. We use the power rule, and then we have to multiply by the derivative of the inside function. So this is 10x. So this, if I simplify this, I have my negative 10x in the numerator. But this negative up here tells me I'm going to put this whole thing in the denominator. So this is going to be 5x squared plus 2 squared. Okay. And so looking at my choices, I have negative 10x. It looks like it's right here. Now this, you would get the same answer if you had used the quotient rule. So either way is correct. All right. Here, the square root just means the power is a 1/2. And also because it's in the denominator, it's going to be negative 1/2. So this is number 27. I'm going to go ahead and f of x equals 1 over the square root of 8x minus 4. I want to write this as 8x minus 4 raised to the power of negative 1/2. Again, the negative means it's in the denominator, like we have here, and the 1/2 means I'm taking the square root. So now, since I have a variable raised to a constant power, I can use the power rule. So when I take the derivative, it's going to be negative 1/2 times 8x minus 4. Subtracting 1 from negative 1/2 is going to be negative 3/2. Okay. And finally, I need to multiply by the derivative of the inside function. So that's going to be times 8. That's the derivative of this in here. That's the chain rule, or if you will, the extended power rule. Negative 1/2 of 8 is going to be negative 4. 8x minus 4. And I can write it like this, or I can write it as negative 4 over 8x minus 4 to the 3/2. I'm not sure which version they have, but let me check. It looks like it's this one up here. No, hold on. Right here, -4, 8x minus 4 to the 3/2 power. That's the one that matches my answer. Okay. I think we've done one like this. Again, you just write this as 14x minus x to the 7th raised to the 1/2 power. And when you subtract 1 from your exponent of 1/2, it's going to become -1/2. That's going to kick it down into the denominator. So the choice is either going to be one of these three. Okay, this to the -1/2 is one of these three. It looks to, and then you got to multiply by the derivative of the inside, which would be -7x to the 6th. So it looks to me like it would be this one, right? Oh, time, and then 14 also, I forgot that. So here, 14 minus 7, it looks like it's this one here. Okay. All right, here you're just going to write this. This is number 29. Okay, number 29 is going to be f of x is equal to 5 over 2x minus 3 to the 4th power. Okay, so you're going to want to write this as f of x equals 5 times 2x minus 3 to the -4th power. Not negative, just means this is in the denominator. So this allows me to use the power rule. -4 times 5 is -20. 2x minus 3, I'm going to subtract 1 from -4, that's -5. Multiply by the derivative of what's inside, that's 2. So we get -40. 2x minus 3 to the -5, and you can either write it like this, or you can write it as -40 over 2x minus 3 to the 5th power. I'm not sure which format they have it in, so let me take a look. All right, it looks like this one right here, C, is the correct answer. All right, here the 303 is going to come out front. Then you're going to subtract 1 from the exponent, so you're going to get 302. So you can see that. And then you have to multiply by the derivative of this inside function, which is 10x to the 4th minus 20x cubed. So that would be this one right here. B is the correct choice. Okay, this one is a little different. You're going to need to use the product rule here. And the reason is because you have a function 5x, that's a linear function. And then you also have a power function. You have two separate functions multiplied. So you're gonna need the product rule. So let me go ahead and do this one. This is number 31. Okay, what did I say that was? 31? I think so. Number 31. Okay, so we this is our first function. I'm going to circle the two functions. This is our first function, and this is our second function. So the product rule says that you take the first function times the derivative of the second. Well, the derivative of this is going to be the 3 comes out front, and then you're going to have 3x plus 3 squared. That's the power rule. And then you're going to multiply by 3 again, because that's the derivative of this function here. Then you take the second function, which is 3x plus 3 cubed, times the derivative of the first function, and that would be 5. Okay, and it looks like they factor out the common factor of 3x plus 3 squared. I think they do that. Let me look at the answers. Again, now you're trying to match your answer. I think it's C. That's I'm pretty sure it's C. So I think they factored out that 3x plus 3 squared. Notice that I have 3x plus 3 squared, and then also I have 3x plus 3 squared plus another factor. So I'm going to take out the 3x plus 3 squared. So we have 3x plus 3 squared, and then we have 15x times 3. That's going to be times 45x. Okay, and then over here, we took out 3x plus 3 squared, but we had an extra one. And then we multiplied that by 5. So it's going to be plus 15x plus 15. And so this is going to be 3x plus 3 squared times, if I combine these two, that's going to be 60x plus 15. And I think they factored out, I want to say 15 from there, but let me see what they got here. See if I can match that with something. They factored out the 5. Yep, C is the correct answer. And notice here, if you factor out the 5, if you multiply this, 5 times 12 is 60, and 5 times 3 is 15. So that's what I got. So they just factored out that 5. They took the 5 out of here, and they were left with 3x plus 3 squared. Taking the 5 from 60 gives me 12x. Taking the 5 out of the 15 gives me plus 3, and this is the answer that they have. So C is the correct answer. Again, I'm going to try to avoid problems like this where the algebra is just too much. I really don't want to make this an algebra test. I just want to see if you know the rules. So, and here's one where you would have to use the product rule. So I'll go ahead and do this one for you. And then let me see what the next problem is. It's section 1.8. So I'm covering that in my next class period. So we'll leave off here at number 32. Okay, so we have y equals x times the square root of x squared plus 1. I'm guessing this one would be, I wouldn't put this on the test because it seems complicated, but let's see how it turns out. I'll do this one for you too. So we have, which is just a linear function, x, and then we have this square root function, which has another, which is a composition. So there's a lot going on here. And when we take the derivative, we're going to, because these two are multiplied, we're going to use the product rule. And so the first function is just plain old x, and the derivative of that is just 1. That's pretty easy. This function here, our second function, the way I would write this is x squared plus 1 to the 1/2 power. And so g prime of x equals 1/2 times x squared plus 1 to the negative 1/2. And I didn't leave myself much room here, but then we got to take multiply by the derivative of the inside. So that's a 2x. So when we simplify this, 1/2 times 2 is just 1x. So it becomes x. And then this negative 1/2 means it's just going to be in the denominator, like x squared plus 1. So this is g prime. Now we're going to plug that into the product rule. Remember, the product rule is the first function times the derivative of the second plus the second function times the derivative of the first. And here are my functions. So we have x times g prime. That's right here. Hi. Oh, do you have class in here? I'm sorry.
It might spend going over, do you have class?
Yes.
Okay, when does it start?
It's not that exactly 3:30.
Is that now?
Yeah.
Okay, I'm sorry.
I will sign out. Sorry, I gotta go. I'll let you finish that one on your own. Thank you.